Hey there everybody, and welcome to the first data analysis video of the course. In this video I want to do two things for you. I want to talk about the kind of data analysis we'll be doing, so sort of just set up this unit for you, and discuss the platform in which we'll be doing it, and that platform is JupyterLab. We will no longer be using Spider for the rest of the course. So the point of this video is just to set up that unit of data analysis and show you how JupyterLab works. How do you open it? How do you run a program inside of it, etc. So by way of introduction, to motivate this unit on data analysis, let me just point out to you that there are many other programming languages out there besides Python. There are various C languages like C++ and C#. There's Java, MATLAB, etc. Of all the languages out there, why does this course use Python? Right, that's a good question to ask about a computer science course that uses Python. And the short answer to that question is, well, because Python is the language of choice of data analysts. People who analyze data use Python. So that, of course, raises a natural follow-up question. Why is Python the language of choice among people who analyze data? And the answer is because Python has all sorts of useful built-in libraries that are built to analyze and process large data sets. The primary such library, and the library we'll be spending our time with for the rest of the semester, is called Pandas, a very cute name. We will be dealing with this library, as I said, for much of the rest of the course. So basically, Python and these libraries that are built for it, these things are built for modern data analysis. Okay, so just imagine that you're, say, a chemist or somebody, and what you've done in your experiment is just taken millions upon millions of measurements of a chemical reaction or whatever it is chemists do. So you've got this gigantic chunk of data, millions upon millions of entries in a spreadsheet. How are you going to analyze that? What programming language is built to help you analyze that most easily? The answer is Python. So everything we're going to do for the rest of the semester could in principle be done by a language like C++, which this course used to use, by the way, could in principle be analyzed by Java, but those languages are just not naturally built to handle data, so it's really clunky to use them. It's very difficult to use them. Python is the easiest language to use to analyze data. Pandas in particular, what makes that so awesome? Pandas is so great because it really nicely just eats in large amounts of data inside your program. So again, that spreadsheet of millions upon millions of chemistry measurements, Pandas can just eat that real easy right into the program, so that now you have an internal copy essentially of that spreadsheet inside the program that you can analyze. Once that spreadsheet has been eaten, Pandas has all sorts of nice built-in commands to help you analyze that data. You want to take an average? Boom, there's a built-in function that does that. Standard deviation, you want it to count things for you, whatever. There are just all sorts of nice little internal commands that come with Pandas that help you analyze data. So again, not to belabor the point, but Python and Pandas in particular built with modern data analysis in mind. You want to analyze a humongous chunk of data, Python is your answer with things like Pandas. Okay, so what's an example of the kind of data we'll be thinking about or analyzing, and what are some questions about that data we'd like answered? I want to show you in a second, but let me just first say that the kind of data you analyze and the kind of data you find interesting depends on you and what your job is or whatever. So again, if you're a chemist, then chemistry data is what you might want to analyze. If you are a mathematician like me, I don't care about chemistry data at all. I work in the political science space, so I care about, say, voting data. What if you get all the precinct level voting data from the state of Missouri or from all the United States? What are you going to do with that? You're not going to open the spreadsheet yourself and look at it. You need Pandas or something to eat it, and then it'll answer questions you want answered about it. So anyway, this data set I'm going to show you first, it's not like the best or most interesting data set out there in the world. That's all sort of subjective. It is a very nice data set, though, in that it allows us to use these commands from Pandas that I want to show you. So let me close this. Okay, so here's the data that we're going to hit for a lot of the course. This is Social Security Administration data about baby names. So I just downloaded this straight from their website. What you get are a bunch of text files that look like this. And text files could be thought of as spreadsheets if you want to think of them that way. So every single state has a text file. So if I open one of them, let me just show you what it looks like in there. Let me zoom in on this so you can see. Okay, so here's what the data looks like. So every single file comes with the state moniker, gender information, year information, name information, and then here's the key piece of data: the number of people with that name in that year with that gender. So there were 295 Marys born in California in 1910 that were assigned a female gender. So this one file here is humongous, as you can imagine. Every person who was born in California from 1910 on, this file goes through 2018, is in here. So if I can just scroll, there's a ton of data in here, right? Like I've scrolled a while, I'm only in the 1960s, right? There's just a ton of data in here. And every state has its own file like this, right? So it's just a lot of data. I should say there's one caveat. If you scroll long enough, you'll notice that there are these 5 counts here. So there were 5 Davidas in 1963 in California. If I keep scrolling, 555. So let me get to where the 5s end. Okay, so these 5s end, and now I move on to 1964. If there were 4 or fewer people with that name in that state in that year, they are not recorded in this file for privacy purposes. So when I say everybody who was born in California is in here, that's technically not true. If your parents gave you a unique enough name, right? 4 hits or less in that year, in that gender, it wasn't recorded for privacy reasons. Anyway, okay, so given this data, this is all, with that caveat, right? All baby name data across all the states and DC since 1910. What kind of questions might you want to answer about this? Well, it depends on you and what your work is. Again, like it's all sort of subjective, but here are some questions we might want to answer about this data. What was the most popular name in California in the 1980s? Right, that's a question you could ask. What was the most popular female name in California in the 1980s? What was the most popular female name across the entire country in the 1960s? In which years were there more male babies born than female babies born? Could you sort of track a male versus female divide across the data? Could you get a nice visual of this data somehow? So your name, like my name is David, right? Is there a way to sort of watch through a graph or a plot, scatter plot or something? Is there some way to watch how many Davids there are over time? Could you plot the number of Davids in 1910, then 1911, and so on up to 2018? You get a nice little visual of that. There are all sorts of questions you might want to ask. I don't know. I was just throwing those out there. Pandas can answer those questions fairly easily, actually, once you eat this data in. So this is the kind of data we're going to look at and the kind of questions we will answer. And again, there's nothing special about this data. It's just this data is very clean, and we can ask all sorts of sort of natural questions about it that will get you comfortable with pandas as a data analysis tool. Okay, so there's an example of a data set that we'll be thinking about. Hopefully, by the way, also I'll get some COVID-19 data. I'm waiting to find some cleaner data sets than what I found that we can analyze without too much work. So, with the COVID-19 data set, you can answer all sorts of questions like, on a given day, how many new cases were there in the US? Whatever. Okay, JupyterLab. That is the platform in which we will be doing our data analysis. It's much like Spider. In practice, for us, it's not going to act much different. It's just there's one sort of crucial difference about it that makes it better for analyzing data, and that reason will become clear as we move on. So I just want to quickly show you what JupyterLab looks like and how you use it. So let me bring up Anaconda. You guys are used to clicking this launch right here for Spider. Okay, so instead, I'm going to click this JupyterLab launch. And let me just say real quick that as it launches it, it opens it in a web browser. Okay, so it will open it in Internet Explorer or whatever. And what it's going to show me here in a second is not going to look like what you will see. The reason is because I've been using JupyterLab a lot. I used it a lot for my own work. So it's real busy, what's shown here. Okay, there's already code here. There's already a bunch of stuff on the left-hand side. You won't see hardly anything like that because presumably you haven't used it yet. So what you will see is something like this. You should see like a blank thing. Okay, you can click here and see how the cursor is blinking. This is a little box, or sometimes I call it a pane or a panel, depending on my mood. Here's a pane where you can put code in. And the code you put in there can be the exact code from Spider, and you can run it the same way as you did in Spider. So let me just put some code in there. Let me just grab it real quick. Okay, here's some code. This code hopefully looks familiar to you. This code will determine if this number n is prime or not. We've seen this code before. How does it work? It just marches through the values 2 up to n minus 1, and if it sees a divisor, we know the number is not prime, so we switch this variable to false. Anyway, this is a program that we've had written for like 6 weeks now. If I click this run button here, it just outputs stuff down here now. So instead of having code on the left and output box on the right, it's like code above and output below. So you can just use this little box right here the same way you did in Spider. The main difference between JupyterLab and Spider is that, notice there's not like a new box right here, right? There's a second box. And I could put code there if I wanted to. And the code that I put here, okay, this is important. This is the crucial reason why we're going to use this for data analysis. This box I put code in here, it will remember the code from previous boxes. So this box here was already run. It's like locked in. And see there's a number right there, number 1. That's telling you this was the first pane that was run. So that's now locked in, and Python knows what all happened here. So for example, if I ask it to print in this box, I hit play, it prints 343. Even though these are separate panels or separate boxes, I ran this here where n was 343, so when I run this next, it knows that n value. Or if I ask it to print here the value of prime, say, run false, right? It remembered from up here that 343 wasn't prime, so the value of prime was false. That's the main difference between JupyterLab and Spider. And by the way, suppose that I put a 345 right here, okay, but I don't rerun this panel. I don't rerun it, and then I ask it to print in right here and rerun that. It still says 343 because I didn't run this code, so the value of n wasn't changed. So whatever happens here gets locked in after you've run it. So now if I come back up here, hit run, and then I come down here and hit run, now it updates it to 345. Okay, so this is what JupyterLab looks like. This is what it is. It basically just has several little boxes of code, and you can sort of lock in code up top, and then down below, any subsequent code you run can remember what was run up top. This makes, by the way, JupyterLab really nice for data analysis, because when you're analyzing data, there are some steps of the analysis that might take some time. It might take your computer, 30 seconds to 5 minutes to do something, like eat a gigantic spreadsheet. If your spreadsheet has like millions upon millions of values in it, it might take it a minute to eat it. You can put that eating up top, though, and run it as its own panel. And then once that data has been eaten, it's been eaten for any subsequent panel. So you don't have to like keep re-eating the data. You can eat it once, do the time-consuming thing once, and then any subsequent panel remembers that. This is different from Spider, right? In Spider, you didn't really have a way of telling it except by commenting things out, but I mean, I guess that's not even relevant either. But there's no way to tell Spider like, hey, do this thing this one time and then later do these other things multiple times. There's no analog of that. So JupyterLab is what we'll be using because we can do time-consuming things up front and then not do them again. Okay, so let me put this back. Okay. What? So that's data analysis. That's JupyterLab. A final comment on this introductory video. I should say, right, I am, of course, aware of the uniqueness of our situation and the corresponding difficulty. None of you people signed up to take an online course, okay? I am, of course, very aware of that. I want you to know that I've given a lot of thought to what this final unit should look like, given our situation, I have tailored the material accordingly. So I have thought about and made choices about what material to cut. Every single thing I cut killed a part of my soul, okay? I don't like cutting things out. Everything that I teach I consider important, or I wouldn't be teaching it, So it has been painful to excise things. I mean, ultimately, what I want is the best course possible and the best for you. The best for you people, you know. I want you to get the best experience learning Python and learning some data analysis as possible. And that's not going to happen now. But, you know, desperate times call for desperate measures. So what I will be giving you instead is sort of you will still be comfortable with data analysis. I'm still giving you a taste of pandas. So you will still get some awareness of what it's like to analyze data with pandas. So just know that, right? Know that I'm not going to try to do everything we were going to do in class, right? That's not possible, and it's not a good way to spend our time trying that. So what I'm going to do instead is tailor things to our current situation, and hopefully things will go smoothly for this last unit.